Okay, here's our second problem where we're going to find critical points and inflection points and all sorts of things with this graph. So we have this nice looking graph here, y equals x plus 1 squared over 1 plus x squared. And we're going to find several things. First of all, we're going to find critical points, then find inflection points, then find a y-intercept, and to see if there's a horizontal asymptote. I see there's one here, but to show the work for all that. So first of all, let's do the first derivative to find the critical points. So this is a quotient, so we're going to have to do our f and g's here. And we know the quotient rule is f prime g minus f g prime all over g squared. So let's set it up here. So I got f is x plus 1 squared. F prime is going to be 2 times x plus 1. G is 1 plus x squared. G prime is going to be 2x. So f prime of x is going to be f prime g, so I have 2 times x plus 1 times 1 plus x squared minus fg prime, so I'm going to put this in a bracket here, fg prime, which is going to be 2x times x plus 1 squared all over g squared. Okay, so I have this here. So first thing I'm going to do is try to see if I can factor some things out. So this is a term right here. This is a term right here, so we can take out what they have in common. And I see, oops, I lost it. I see I can take out a, whoops, there you go. I can take out a 2 and an x plus 1 out of both of those terms. And when I do, I have a 1 plus x squared minus x times x plus 1 all over 1 plus x squared squared. And then I can combine what's inside the bracket here. So I have f prime of x is going to equal 2 times x plus 1 times, and if I do this here, this will be a negative x squared. If I do this here, and if I do the distributive property, that's minus x. So the x squareds kind of cancel out, so I end up with a 1 minus x in here, all over 1 plus x squared squared. So there's our first derivative. So I'm going to set this equal to 0. And when we do that, I like to do 0 over 1 because then we can cross multiply and find out what to do. Remember, you can find critical points by putting it equal to 0 and where it's undefined. And if you look at it down here, there's no way I'm ever going to get the denominator to equal 0 no matter what I put in there. So we're not going to be able to use the denominator at all. So when I cross multiply, I have 2 times x plus 1 times 1 minus x equals 0. Do the big T here, and 2 will never equal 0. X plus 1 equals 0. 1 minus x equals 0. So x equals negative 1, and x equals 1. So there's two of our critical points. And if we plug this back into the original, this is negative 1, 0, and this is 1, 2. It also shows here on the graph, but there's our two critical points. So I'm going to start listing everything here. So on the side here, I'm going to say, all right, our critical points are going to be negative 1, 0, and 1, 2. And I'm not for sure what's a local max and what's a local min, so we have to check that by looking at our f prime bar. So we're going to put an f prime bar right here to see what the local max and local min would be. So you have negative 1, 0, and 1, 2. And I go through and I fill this in. I find out that negative 1, 0, so this is negative 1, it's going to be a negative here when I plug in the number. And remember, I always go to the factored form. So if I throw something in less than negative 1, I'm going to have like a negative 2. This will be negative here. And if I negative, this turns positive. Positive times a negative is negative. Then here, between negative 1 and 1, if we throw a 0 in here, that's positive times a positive, so that's positive. if I throw something larger than a 1, this will be negative times a positive, so this is negative again. So if you'll see this goes down, so this is a local min, and this is positive and negative, so this is a local max. So I can go up here, let's give a little space between these two. So negative 1, 0 is a local min. 1, 2 is a local max. So we've talked about critical points. The next thing I want to find, we have to find some inflection points. So I'm just going to keep going down here on the right hand side. So I've got some inflection points to see what I can find. So we're going to have to do the second derivative. And this is a little bit more involved because I have to actually use, I'm going to use a different color here. For the second derivative, I have to actually use this whole thing right here for the second derivative. So when I do f, oops, erase that. So when I do f double prime of x, my f is going to be what's a green here and g what's a yellow. So I can set it over here if you want, whatever. So I'm going to, my f is going to be, I actually multiplied that all through. It's negative 2x squared plus 2 because I don't want to do the product rule. And so my f prime is going to be a negative 4x. So all I did to get this was I multiplied that green through, okay, so that I can do the power rule. G is going to be 1 plus x squared squared. So g prime is going to be 2 times 1 plus x squared to the first power times 2x. So g prime ends up being 4x times 1 plus x squared. Alright, so I'm going to move this down a little bit so we can do the second derivative. So the second derivative, which is also the quotient rule, is f prime g squared minus fg prime. So that's going to be negative 2x squared plus 2 times 4x times 1 plus x squared all over g squared, which is 1 plus x squared squared squared, so that's going to be to the fourth power. So now we got to go through and kind of do some of this algebra here. So what I did was actually factor out of this, because here's a term right here, if this doesn't freeze up on me. There's a term right here, and I have a term right here. So I'm looking at everything I can factor out of there. So if I take out a negative 4x, 1 plus x squared, I know I have a squared there. Out of that term, I have a 1 plus x squared left out of this. Alright. The sign changes if I'm dividing by a negative here. So this is negative divided by negative, so it turns positive. And I have a negative 2x squared, okay, plus 2, because I've taken all this out of here. So this is gone because I've taken that all out of there. All over 1 plus x squared to the fourth. Now by doing that, what makes it nice here is this is a factor, and this can change to a 3 now. And I can simplify the numerator a little bit. So the numerator comes out to be negative 4x times a negative x squared plus 3. So this negative 4x, and then I simplified everything in here. I combined these, the negative 2x squared and the x squared, and the 1 and the 3, all over 1 plus x squared cubed. Now, finally, we got it to a point where we can put it equal to 0. I'm going to do 0 over 1. So when I do that, I cross multiply. I have, I'm going to bring this over here, negative 4x times negative x squared plus 3 equals 0. And then, oops, I'm going to make big T. So I have negative 4x equals 0, x equals 0. And then I have negative x squared plus 3 equals 0. So x squared is going to equal 3. X is plus or minus radical 3. Wow. Took us a bit, well, we got there. So I know my inflection points are going to be, and if we look at our picture, the radical 3 kind of already showed up here. The 0 is also a change of concavity here, but right here we're going to put down our points here. So I have radical 3 something, negative radical 3 something, and I plug them back into the original function, so I get 1.87 for this one and 1.34 for this inflection point. Now the other thing I want to show you that we have here is, this is an interesting function because the y-intercept, okay, if we were trying to figure out where x is 0, if I put a 0 in there, the y-intercept is going to be at 1. So we can add that here. The y-intercept is going to be at the point 0, 1. So we have that there. And the other thing we have here is a beautiful horizontal asymptote. Now the horizontal asymptote is y equals 1 from the picture, but I want to show you that you have learned that before, because if this was our function, which was x plus 1 squared, so it's x squared plus 2x plus 1 all over 1 plus x squared. If you'll notice, the highest power of the two, that can make our horizontal asymptote as y equals 1. So there, I've given you everything that you can do on a graph like that.